All right, let's transition to talking about the arithmetic series. So the sequence, if you remember, is just the list of terms. The series is when you add the terms together. So we don't think of adding all infinitely many terms of our infinitely long sequence. Instead, we take an nth partial sum. We just add some of the terms from the sequence. So for an arithmetic series, this is it. Remember the notation for the nth partial sum, capital S sub n. And here we've got this really nice formula. We might not have to actually go and physically add just find each number and add them all together like we did in 12.1. Now we've got this really cool formula. So if you want to find the sum of the first n terms, the nth partial sum, take that value n over 2 and multiply it by the sum of simply your first term and your nth term. Let me show you an example of exactly what that looks like. So we'll try and keep that formula on the screen. Find S10, the 10th partial sum, for an equals 2 plus 5 times n minus 1. Okay, we saw that. That's the example from the beginning of this lecture. So if we use our formula, it would say, okay, the 10th partial sum, that's when n equals 10, right? 10 terms we're adding. I also need that first term a1. Okay, I can identify that right here. That's 2. That's my first term. But I'm also going to need the nth term, which for us is the 10th. If n equals 10, we want the 10th term. Okay, the first term and the 10th term. Well, no problem. I'll take the 10 and I'll just plug it right in here and I'll find that 10th term. So if I plug it in, trying to darken some of these numbers for you. 2 plus 5 times 10 minus 1, that's 2 plus 5 times 9, ends up being 47. Okay, so I got my how many terms there are, the first and the last. If I put all those into my formula, there it is. I think I'll just kind of move this up. So how many terms are there? 10, 10 over 2. And then we add together the first and the 10th. And if you think, okay, well, that's 5, that's 49, right? Got an arrow there. I'm going to draw back to that in a moment. But 5 times 49 is 245. So if we were to add the first 10 terms together, we'd get 245. I'd like to take a moment and just explain why this formula is what it is, because it's actually is pretty interesting the way it works out. And it really comes down to this 5 times 49. So that's why I've got this arrow here. Who came up with this formula? And just why is it what it is? It's just kind of seems out of the blue, right? Take 10 over 2 and then add the first and the 10th term to get the sum of the first 10. Think of 5 times 49 as 5 pairs of 49. Okay? It's 49 5 times, but each of those 5 times are actually pairs of other numbers. So we see one pair here, 2 and 47. That pair makes 49. And it turns out there are 4 more pairs if we thought about adding these 10 numbers together. Let me show you what I mean. Why this formula? Okay, let's think about doing it the long way here. So you may or may not actually write all this down. This is just the explanation of the formula. You know, for tests and homework, you just need to know what the formula is. But it's pretty cool how it works. So if I just went and listed out the first 10 terms of that sequence, that series. So remember it was 2, 7, 12, 17, 22. Then if we kept going, 27, 32, 37, 42, 47, and that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. Okay. You think, okay, where does this 5 times 49 come from? 5 pairs of 49. Well, one pair of 49, we already saw in the formula, it was 2 and 47 make 49. Do you see any other pairs of 49? You're like, oh, well, what about 7 and 42? They make 49. Yep. And 12 and 37? How about 17 and 32 make 49? And finally, 22 and 27 make 49. So how many 49s are there? Well, 1, 2, 3, 4, and 5. And when we get to the middle, that's our last pair. That's the fifth pair. We had 10 terms, right? So if you cut that in half, that's how many pairs of 49 there are. So look back at the formula. 10 divided by 2, because everything's going to pair up, kind of as we work to the middle. And then all I got to do is figure out what they're all adding up to. Well, I'll just take the first and the last. And then I'll know all the other ones are going to pair to the same thing. So 5 pairs of 49, 245. That is genius. There's a story of some people put Einstein in this story, but it's not Einstein. It was this guy. His name was Gauss, Gauss. I want to say he was German. I might be off with that. So anyway, considered by many to be the best mathematician who ever lived, Gauss. And his name is on all kinds of stuff when you get to higher and higher levels of math. So the story goes, when Gauss was a kid, think like elementary school, like maybe 4th, 5th grade, something like that. His class was acting up, and their teacher did not like it. The teacher was really frustrated with them, and the teacher just said, okay, everybody sit down. I want you to add the numbers from 1 to 100. Okay, so he tells this to these kids, and he thinks, great, I got probably at least a half an hour of peace. I can just try to, unwind a little bit while these kids just work at their desks. So in less than a minute, Gauss, as a little boy, is in the class, so he adds the numbers from 1 to 100 using this method. And in less than a minute, he walks up and says, asks his teacher, is this right? And the teacher's just blown away. So what did he do, right? I mean, 1 plus 2 plus 3, and you think all the way up to plus like 98 plus 99 plus 100. There are 50 pairs of 101, right? 101, 101, 101. So what's 50 times 101? Well, that's going to be the sum of the numbers from 1 to 100, right? And you can get it in just a few seconds if you think of it that way. All right, anyway, interesting story. We got one example of an nth partial sum. Let me get that off the screen so we don't need that anymore. Let's find the sum of the first 50 terms, and all we're given is the nth term, a sub n equals negative 2n plus 8. Okay, the sum of the first 50. Well, I don't know about you, but I don't really want to write all those 50 terms out and then add them up the long way. Good thing we've got our new formula, so we can do this much quicker. S sub n equals n over 2 a1 plus an. All right. Well, we know what n's going to be here, right? 50. There are 50 of these terms. What's a1 and what's a50? Oh, I wrote the formula there. Great. Predicting my own notes. All right, we know n equals 50 again. A1. So you notice that this sequence is not written in the nice form a1 plus d times n minus 1. It's still arithmetic. It's just not written quite that way. No big deal. If we want to find A1, we can just plug 1 right in. And it turns out A1 equals 6, negative 2 times 1 plus 8. We also need to know the 50th term. No problem. Plug 50 right in. Negative 2 times 50 plus 8. Negative 100 plus 8 is negative 92. So we know how many terms there are. We know the first term. We know the 50th term. Put all that in. 50 over 2, 6 plus negative 92. So simplifying a little bit first, that's 25. And negative 86. There would be 25 pairs of negative 86. If we were to match them up end to end, well, what is that product there? Negative 2,150, the sum of the first 50 terms. Very easy when you think of it that way. Well, that is the end of 12.2, so go check out the homework. See you then, or come to the live session. See you there.